Welcome, everyone. On June 24, 2021, the 12-story Champlain Towers South Condominium in Surfside, Florida partially collapsed, tragically killing 98 people. This disaster shocked engineers, officials, and the public, prompting urgent investigations into why a 40-year-old reinforced concrete structure could fail so catastrophically. Early findings and expert analyses have pointed to a key contributing factor: long-term deterioration of the building's reinforced concrete caused by chronic water ingress and subsequent corrosion of steel rebar. In other words, water had been penetrating critical concrete elements for decades, leading to hidden structural weakening. This case starkly illustrates how water ingress, due to design flaws or neglected maintenance, can set off concrete failure mechanisms that undermine a building's integrity. In this seminar, we will examine the Surfside collapse through the lens of concrete failure mechanisms. We'll focus on how water infiltration and waterproofing failures likely contributed to the collapse and why proper waterproofing is critical to protecting concrete and reinforcing steel. Key processes like concrete carbonation, chloride ingress, and rebar corrosion will be explained in an accessible way. Ultimately, the Surfside tragedy offers a cautionary tale. Investing in effective waterproofing and maintenance isn't just about avoiding leaks. It can literally save lives and significantly reduce life cycle costs for owners and stakeholders. Multiple investigations by engineers, Miami-Dade County, and NIST are ongoing, but a consensus is emerging that water-induced damage played a central role in the Surfside collapse. In particular, attention is focused on the pool deck and parking garage areas, where evidence of long-term water penetration and concrete deterioration was well documented years before the collapse. In October 2018, an inspection by engineer Frank P. Morabito revealed major structural damage in the concrete slab beneath the pool deck, as well as extensive cracking and spalling, concrete breaking apart, in the parking garage columns. Crucially, the report identified the cause. Failed waterproofing on the pool deck and planters had allowed water to seep into the concrete slab and attack the reinforcing steel. In a letter to residents, the condo board warned that large sections of the pool deck had no effective waterproofing, leaving the garage ceiling and structural slab exposed to water intrusion for 40 years. Even where a waterproofing membrane existed, it had deteriorated past its service life, allowing water to get underneath and cause concrete damage. The 2018 Morabito report urged prompt repairs. All the failed waterproofing needed to be removed and replaced to stop ongoing damage. The report starkly cautioned that if waterproofing was not fixed soon, the extent of the concrete deterioration would expand exponentially. In the same report, Morabito noted that many prior patchwork concrete repairs in the garage were already failing, likely because the root cause, water intrusion, had not been addressed. Unfortunately, these critical waterproofing repairs had not been carried out by the time of the collapse in 2021. The Condo Association had approved a $15 million package of remedial works, including pool deck and slab repairs, for the 40-year recertification, but work had barely begun when disaster struck. Why is water such a nemesis to reinforced concrete? In reality, concrete is a porous material that breathes and absorbs moisture. Reinforced concrete is essentially a steel frame encased in concrete. The concrete provides strength and, importantly, chemical protection for the steel. When intact and dry, concrete's natural alkalinity forms a thin oxide film on rebar that prevents rust. However, if aggressive agents penetrate the concrete, they can destroy this protective environment and let corrosion run rampant. The Surfside collapse highlights key deterioration mechanisms related to water ingress. Carbonation. Over time, atmospheric carbon dioxide dissolves in water and diffuses into concrete, reacting with calcium hydroxide to form calcium carbonate. This process, called carbonation, lowers the pH of the concrete. Normally, new concrete's high alkalinity, pH 12-13, keeps rebar passive. But when carbonation front reaches the depth of the steel, the pH may drop enough to break down the rebar's passive oxide layer. Now, if moisture and oxygen are present, the steel will start to oxidize. Rust occupies a greater volume than steel, so it exerts expansive pressure inside the concrete, causing cracking and spalling of the concrete cover. Once cracks form, even more water and CO2 can enter, accelerating the corrosion cycle. Carbonation is generally a slow process, taking decades to reach deep rebar in thick, dense concrete, but it is accelerated by exposure to water, which helps CO2 permeate, and by concrete with high porosity. In Surfside's case, 40 years had passed, enough time for significant carbonation depth, especially in constantly damp concrete. Chloride ingress. Chloride ions are extremely corrosive to steel reinforcement. They penetrate concrete primarily via water, seawater, brackish groundwater, salt air, or de-icing salts in colder climates. When chlorides reach steel, they destroy the protective oxide film even if the concrete is still alkaline. In effect, chlorides bait the steel into corroding by creating localized anodic sites. A key fact is that water is the electrolyte that enables chloride-induced corrosion. Dry concrete, even if full of salt, won't corrode steel because ions can't move without moisture. But in the presence of water and oxygen, once chloride has breached the concrete cover, corrosion will proceed rapidly. Champlain Towers South, situated near the ocean and built over a saltwater water table, was undoubtedly exposed to chloride sources. Sea salt in the air, wind-blown salt spray, and possibly saltwater intrusion from below could all contribute chlorides. Additionally, the pool deck might have been exposed to salts. Chloride attack likely worked in tandem with carbonation and directly with water to corrode the rebar over the years. Essentially, moisture is the enabler. Without water, neither carbonation-induced nor chloride-induced corrosion can progress much. This is why dry concrete structures remain durable for so long, and conversely why persistently wet concrete can degrade significantly in just a few decades. The Surfside collapse vividly demonstrates that waterproofing is not a luxury or cosmetic concern. It is fundamental to structural safety. A proper waterproofing system acts as the first line of defense to keep water out of concrete. If the Champlain Towers South's pool deck and garage had been effectively waterproofed and maintained, water would not have been able to infiltrate the concrete slab and corrode the rebar as it did. In fact, Morabito's plan for repairs in 2018 was to completely rebuild and re-waterproof the pool deck and planter areas to halt the ongoing corrosion. Sadly, that work was not completed in time. Why is waterproofing critical? By preventing water ingress, a good waterproofing system addresses all three deterioration mechanisms we discussed. It keeps out the moisture that enables carbonation to reach steel. It blocks chloride-laden water from penetrating. And it generally keeps the concrete drier. Durable concrete with low permeability and sound waterproofing can easily last its design life with minimal steel loss. But if waterproofing fails, deterioration can set in within a couple of decades, especially in aggressive environments. At Surfside, the original design had a flat pool deck slab that allowed water to pond, and the waterproofing present in 1981 was well past its lifespan by the 2010s. Once cracks formed in the concrete and membrane, each rainfall would send water seeping into the structure. Over 40 years, this unchecked leakage effectively rotted the steel skeleton hidden in the slab and columns. For building owners, developers, and maintenance teams, the Surfside case is a dramatic wake-up call about the value of proactive waterproofing and repair. The life cycle cost implications are huge. Investing in quality waterproofing during construction and replacing or repairing membranes as they age can save orders of magnitude in costs and prevent loss of life down the road. In Surfside's case, a 2018 estimate priced the necessary repairs at $15 million. Those repairs were postponed, and by 2021 the building was lost entirely, leading to $1 billion plus in property losses, not to mention the human cost. This is the ultimate example of the high cost of low maintenance. Conversely, proactive maintenance and waterproofing yield long-term savings by extending a structure's service life. Experts recommend performing periodic structural condition surveys and implementing a life cycle cost analysis for maintenance of waterproofing systems. Such analyses help quantify how spending, say, $100,000 on waterproofing and concrete repairs today could avert having to spend $10 million on major rehabilitation or litigation later. Waterproofing and protective coatings are relatively small investments that enhance durability and can add decades to a concrete structure's life. They also preserve the safety and usability of the structure, which is priceless from an owner's perspective. The collapse of the Surfside condo was a preventable tragedy rooted in a common culprit: water. When water is allowed to permeate concrete unabated over years, it sets off a chain reaction of deterioration, from carbonation and chloride attack to rebar rust and concrete cracking, that can ultimately compromise an entire building. For owners, designers, distributors, contractors, and applicators in the construction chemicals industry, the lessons could not be clearer. Waterproofing is critical to structural health. It shields the reinforcing steel and concrete from corrosive agents, directly affecting the longevity and safety of the structure. The Surfside case shows that neglecting waterproofing can have dire consequences. Regular inspections and maintenance save money and lives. Surfside's 2018 survey identified the issues, but delays in repairs allowed the damage to worsen. Building stakeholders should take warning signs of leaks, cracks, and spalls seriously and address them promptly. Proactive maintenance is far less costly than reactive repairs or disaster response. Concrete durability is a shared responsibility. Designers must detail proper waterproofing and durable concrete mixes. Applicators must install these systems correctly. Owners must fund maintenance and insist on periodic reviews. A breakdown at any point can threaten the structure's integrity decades later. As professionals in construction chemicals and building technology, we have the solutions. We must also communicate their importance to clients and end users. The Surfside condominium collapse stands as a somber case study of why waterproofing and water management are absolutely essential in concrete structures. By learning from this failure and applying its lessons, using proper waterproofing design, quality materials, and diligent upkeep, we can protect our concrete assets, ensure public safety, and optimize the life cycle cost of buildings and infrastructure.